Hello everyone. Today let's solve the problem number 102, binary tree level order traversal. So you can just go through the question and they have given the examples as well. You can just try to understand the question with the help of example. So let me summarize the question for you so that it will be easier to understand. So we are given the root of the binary tree. Clearly you can see here. We are given the root of the binary tree and we need to return the level order traversal of its node values. So what we need to return here? We need to return the level order traversal of its node values. So what do you mean by level order traversal? This means we have to traverse the tree level by level from left to right. Again, I'm telling we need to traverse the tree level by level from left to right. That's what the level order traversal means. Let's consider the example one here. So here you can clearly see root they are mentioned here. So when I say level order traversal here, we need to traverse the tree level by level, right? First, this is first level. So this is second level, and this will be the third level. This is first level, second level. Root will be the root node will be the first level. This will be the second level, and this will be the third level here. You can clearly see. So 3, 9, 20. This we are considering null and null. So that's what they have given here. And finally 15 and 7. So what we need to do here is we have to push or add the element at the particular level to the newer array. So here first level we have to add this element to the new array. See here you can clearly see, and 9 and 20 this belongs to the level 2, right? This is level 1, this is level 2, and this is level 3. So we are pushing the level 1 elements in the level 1 to the newer array, elements in the level 2 to the newer array, and finally we are pushing the elements in the this one level 3 to the newer array. So here you can clearly see the output 3, 9, 20, 15 and 7. So I hope this is clear. Let's move on with the second example. So here they have considered only one one element. So the output will be we are pushing that element to the newer array. When we have the empty array, we need to return the empty array. So the output will be empty array itself, right? So I hope the question is completely clear. Let's discuss the approach and followed by edge cases. Let's discuss the edge cases one by one. Then finally, let's write the code and discuss the complexities of the code that we have written. Initially, let's discuss the approach first. So here we'll be making use of the BFS. So breadth first search, right? So we'll be making use of the BFS level order traversal to solve this particular problem. So first thing is we'll be making use of the queue, right? So usually we'll be making use of queue, nothing but FIFO data structure, first in first out, to traverse level by level, right? So we need to traverse level by level. We have already discussed this one in the question. So we'll be making use of the queue, nothing but FIFO data structure to traverse level by level. First, what we will do, we will start by pushing the root into the queue. First, we will push this one, root into the queue, right? Then we will process all the nodes at the current level. So we'll push this one. Then we will start by pushing the root into the, process all the nodes at the current level, collect their values and add their children to the queue here. This one followed by this one, right? We'll collect the value of the values and then add their children to the queue. First, we will collect the value of it, add the children 9 and 20, followed by same thing 9. This doesn't have anything here. We'll ignore this one. And finally, we'll come to 20 and we will add this one, 15 and 7, right? So we will repeat for the next level until the queue is empty. So that's what we'll be doing here. This is the approach that we'll be going with, right? I hope the approach is completely clear. Let's discuss the edge cases one by one. Then let's write the code. So the first edge case here will be empty tree. This one, let me consider here empty tree, right? For the empty tree, I'll just come here. Let me consider input root empty. Yeah, no elements. We are considering the empty tree, right? Output will be empty, empty array. So because we are not having any element at all, right? So output will be empty array. This second edge case will be only root node. So we'll just consider one element, that is nothing but only root node. So let me give here root. Let me consider 1. This is fine. The output will be, we have to push that one to the new array, right? So the output will be 1, right? So this is for the only root node. I hope the second edge case is clear. Let's move on with the third edge case. Nothing but tree with the uneven depth. Well, I say tree with the let me consider this one. Tree with uneven depth. So here, let me consider this example. 1, 2, 3 here. This one, for this this will be 1, 2, this one null, null, 3, null, null. So this will be the input and the output will be here 1, 2 and 3 here, right? Yeah. So this is for the tree with uneven depth. I hope all the edge cases are clear here. First one was for the empty tree. Second one was for this one, tree with only root node. And third one was for tree with uneven depth. I hope all the edge cases are clear. Now let's start writing the code. So let's start writing the code. We have already discussed the approach. So we'll go with the BFS, level order traversal, right? First, this one is, if the tree is empty, we have to return the empty array. We have seen this one in the edge case. So let's discuss this one. If not of root, then we will return empty array. We have to return the empty array, right? So I hope this is clear. Next step is we have to initialize the result array and queue with the root node, right? I'll just give here for the result array, let me consider res here, and for the queue I'll just consider queue. This is fine. Queue within this one we have to consider root, right? Queue, we are considering the root node within the queue. So next we have to process while queue is not empty. Queue should be having some element within that one, right? We have to process while queue is not empty. So let's consider while loop here. Let me quickly give here queue dot length. This is fine. Within this, let's extract the values of nodes at the current level. We have to extract all the nodes and its values at the current level. I mean, at the particular level, right? So how can we extract here? Let me give here result dot push q dot map n, nothing but the nodes, single node, value of the node we need to extract at particular level, nothing but n dot val. I hope this is clear. This line, line number 7, what we are doing, we are just extracting the values of the nodes at the particular level or the current level. Then we have to add the next level nodes as well, right? So we are extracting the values at the current level. That is fair. Next, we have to add the next level nodes as well. So how can I articulate that one in the form of code? I can just give here, we have already considered here queue. You can see here. We have given, we have mentioned root node within the queue initially, right? Queue, let's make use of the, this one, flat map here. Flat map because we have to add the elements within the new array, right? That is the reason I'll be making use of the flat map here. So here within the array, this will be n dot left, n dot right. I hope this is clear. Let's make use of the filter of Boolean, right? I hope this is clear. This line, we are just adding the next level nodes, right? So the final step, let's return final level, final level order traversal result. We are returning the final level order traversal result, nothing but it will be in the result, right? So let's return here result. This is fine. So let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button now. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written. So first thing is the approach that we went with here is this one, BFS, breadth first search, that we know. And what would be the time complexity here? The time complexity would be, overall time complexity would be big O of n. Why the overall time complexity would be big O of n here? Because we are visiting each node once, right? We are visiting each node once. And what would be the space complexity here? The space complexity of the code will be big O of n as well. Why the space complexity would be big O of n here? Because in the worst case, the queue stores all the nodes at the last level. This one we have to keep in mind. In worst case, we are making use of the queue, BFS and queue, right? In worst case, the queue can store all the nodes at the last level. That is the reason space complexity would be big O of n. Here, overall time complexity and the space complexity of the code would be big O of n, right? I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.